looks like that everyone are experienced developers here, and probably most of the things that will be presented in this during next 20 minutes are yesterday news to you, but I still hope there will be something useful or at least entertaining. Okay, so my name is Yevhenii. I'm a software developer for over a decade, worked on a relatively large code bases. The largest that I worked was almost 300,000 lines, backend, front-end included. Interested in software development principles and practices. And this talk is purely practical. The moment when I started to be interested in software development principles and practices is when I was building my own product. And me and my partner, we hired 2 junior developers, and we was on quite a budget, and we needed something, some kind of framework, or we didn't know what exactly would it be, but something that will allow junior developers to be productive and to understand the code base without spending, I mean, within a reasonable amount of time, considering they didn't have a lot of experience navigating the real production code bases. So I think it worked fine, and the ideas that I will be talking about here, they are based out of this really practical need. So let's dig into this. I guess most of us here are doing web development or did web development, and probably are familiar with Rails, which is probably one of the most popular MVC frameworks. And surprisingly, it gets MVC completely wrong, at least in the model part. The thing is that original inventor of an MVC, I'm struggling to pronounce his name, Trygve Rinskaug. He said that his idea was that there should be a one-to-one correspondence between the model and its parts on the one hand, and the representation of a world as perceived by the owner of the model on the other hand. And Rails Rails is a beautiful framework. It opened the gates to software development, into software development to many folks out there, and led to creation of many beautiful startups. Also, it created a massive market for companies that are fixing broken application designs. And the vast majority of those broken designs, the problems of those broken designs are rooted in the model part or model layer. You probably heard about skinny controller, fat model approach if you spend any considerable amount of time in the Rails community. But the way the model is done in Rails, it's absolute. It almost pushes developers into a completely opposite approach that was intended. And the reason for that is that it's quite strongly coupled with the active record. Every time you create a model, it's inherited from an active record. And active record is really convenient for representing super simple domain models. Basically, that has almost nothing else to do except for the CRUD actions. Create, read, update, delete, that's it. And it goes completely out of hand when you need to represent more or less more complex domains. And almost every application except a super simple one that would be developed over a weekend is much more complex that active record pattern can accommodate. On the other side, it also, additionally to that, it also couples design to the data representation of an underlying storage. And it's a known fact that object-oriented design, or the way we design applications in Phoenix, it doesn't map to the relational model of the underlying databases that we are using most of the time. Notice also that how Trygve didn't say anything about correspondence between model and database design in its original idea. Also, there are all kinds of different problems with this approach. It violates a single responsibility principle, and you have more than multitude reasons for object to change. There is the data itself. It crosses object boundary, which is not ideal. So there are a lot of trade-offs. On the one hand, we have a convenience, and on the other side, we have a lot of trade-offs that we need to understand to use this kind of approach wisely, and most importantly, know when to switch to something more adequate to the situation. And as you know, Phoenix was born in Rails community. It's exceptionally well thought project with lots of fixed shortcomings comparing to Rails. For example, presentation layer is not one global shared space anymore. We have nicely isolated views for every controller and can build our abstractions without worrying about breaking something on a seemingly unrelated page. In my opinion, routing is much better done in the Phoenix, etc. But also it has a birthmarks. And one of the biggest birthmarks is the model layer. When Phoenix was released in its early versions, it has model view and it has controllers use and models, and that because it used completely different persistence pattern. People was a bit confused how to deal with that model, right? Because we had because in Rails community there was this kind of notion that if you have a model, it's backed up by the database. And in Phoenix, model was just as we know, it was just a description of a schema. And despite that, developers were still tried to put their logic in that file without going in, without coming up with a larger abstractions that will better describe their domain. Guys in the Phoenix team saw that and they decided to say, no, okay, this is inertia, but this is not how it should be done. How it be done, and rename it model to schema. And that caused a lot of confusion. Like our models are gone, where we should be putting our business logic. And that's how context was born. So now we have this nice separation of how our database how our data is stored in the database and the logic that operates on that data. Still, it looks surprisingly similar to the active record pattern, with the only difference that in active record we all the methods that we are using are inherited, and in context they're explicit. And in my opinion, this idea of coupling application design to the underlying persistent storage is the thing that slows us down and leads to a broken application designs that have become harder and harder to maintain over the time with the time. And I hope, I mean, my opinion that this one thing, this should go. This should go away. This is this approach of looking at our application design. It should be left behind. because our models, our domain model shouldn't be bound to underlying storage. Original MVC didn't even assume the presence of storage. If we want to throw in the storage, maybe it should be a different pattern: model view controller persistence, or model view controller storage. The way it was done in Rails was just for convenience, and the trade-offs of that are immense. For example, a thinking inertia in the community. Tony Hoare, who invented the concept of null, once said that he did it just because it was very easy to implement, and later he regretted about it and called it his billion-dollar mistake. I think the idea of coupling domain logic to database representation is a billion-dollar mistake of a web development. Later, Trygve Rinskog, in his second iteration on a paper, wrote that a model is an active representation of abstraction in a computing system, and model represents knowledge. So there should be nothing. We shouldn't be constrained by the database representation. We should be thinking of how users are using the system. We should be thinking about how stakeholders, what use cases stakeholders are expecting a system to implement. And going back to the context, here is a quote from Chris McCord explaining the rationale behind introducing contexts. Writing any non-trivial application to model a given domain can be distilled into follow the steps and you are done. What we can do is nudge people into proper mindset when designing an application to set them up for a long-term success, which is a very reasonable and practical approach. We cannot tell people how to write software, but we probably can communicate the mindset that will help them to find their way around the domain complexity. Yet something went wrong, because if you look at the Phoenix documentation, particularly in the section related to Phoenix context, we will see that context, according to the Phoenix team, are dedicated modules that exposes and group related functionality. For example, anytime you call Elixir standard library, be it logger or a stream, you are accessing a different context, which, in my opinion, it can be true when you are looking from the inside the context, right? You can see some boundaries, and you're saying, okay, I'm within those boundaries, and just everything that is within the same boundaries are like in one context with me. Technically, we can say that, but it's about it's similar to saying that every single cable here have its own context. And then when you want to understand interdependencies, their interdependencies, it will be really hard. Let me show the illustration. This part of the code is taken from the Bytepack application by Dashbit, and Dashbit is composed by the people that are partially consist from the people who are Phoenix core team. So I'm expecting this to be idiomatic approach to using a Phoenix context. And what you can see here is a completely broken encapsulation, right? We have purchases context, and then it reaches inside of the sales context and purchases context. And almost every single Phoenix application that I saw is doing that. So we can say that okay, we have a purchases context, but inside it we have at least 3 other contexts: purchases context itself, sales context, and packages context. So is this really a context? I think no. And a few dozen entities later, it's just a mess. It's hard to navigate. You have to spend time debugging. You have to spend time to rebuild the sorry for the lack of words, but you have to rebuild context when you are working with it. You have to drill down into different parts of the application and combine knowledge from different places to understand what's going on. So it's absolutely not well isolated. And when we are talking about context, I would love to use this definition from linguistics, which says that a context is a frame that surrounds the event or entity and provides resources for its appropriate interpretation. We can extend it. We can use an example of words that have words can have different meaning depending on the context. I know that same English words can have different meaning in Australia and United States, for example. Or we can say something that is completely appropriate within the one group of people, and that would be completely inappropriate within other group of people. There is another definition of the context that is closer to software development. It also comes from the Trygve in his latest work, data context interaction, and he defined a context as something that gives a role to an object. So we are taking an object, putting it in a context, and that object will behave differently. We can think of a transaction or a transfer, let's say transfer, that can have a different meaning in a accounting context and in logistic context. So this is just an interesting idea to tinker with, and I will provide links to the DCI website in the later slide. Okay, Phoenix context. So the best case is just an active record, an implementation of active record that is suitable to for very simple models that are just bounded by the create, read, update, delete actions, and in the worst case, it's just a mess. There are different ways you can bend it. It's possible, for example, to create an identity object from it, or use as an aggregate to something that upholds domain invariants. But in its default presentation, in the way that is presented to the users by default, it's just masking those opportunities and pushing people into other direction. But there is an alternative, and that alternative is very well known in software development. It's known by different names in different approaches, but the one that I'm quoting here calls it an interactor. And here is how it uses it. The quote: "You don't let your controllers know anything about the business rules. Instead, the controllers unpack the HTTP request object into a simple vanilla data structure, and then pass that data structure to an interactor, to interactor object. And interactor object implements the use case by invoking business objects. The interactor then gathers the response data into another vanilla data structure and passes it back to the UI. Meaning that we have an orchestrating object. Sorry, the next slide was just misplaced. And that orchestration object, it separates being from doing, right? We have, for example, a user that is an entity. It's something, and then we can say what logic what actually we can do with that user. Of course, within the more complex or within more rich domain model, we can introduce more layers. For example, a domain service or an aggregate that will, repository that will act on users exclusively. The flow might be the following. And a request is coming on HTTP controller. HTTP controller invoke a use case that is, for example, register new user. And then that use case or interactor or action or saga takes a user schema or actually and is doing something with it, like inserting, etc., etc. If we need more complex logic, we can add a domain service, a user domain service that will encapsulate all the knowledge related to the user schema and abstract the database away from our domain layer. Here is an example of a controller action that is doing something similar. On the first line, within the post block, you can see that we are gathering the data that is necessary to perform a use case, and by that we are separating the view layer from the domain layer. Then we are looking up account creation use case for exactly that data. Maybe it's a guest user, maybe it's not a guest user, and that can be two different use cases. We don't need to bend objects to accommodate different situations that shouldn't be aware of, that they shouldn't be aware of. We just separate it here. And then we run that use case and send as a response accordingly. Interestingly enough, that this approach also allows us to draw a boundary between a controller and the model. And if we have a behavior for use cases, we can mock them and test separately from controllers. And that also gives us a chance to introduce acceptance tests, external acceptance tests that will test our system end to end, which is another nice effect of separating, of adhering to the MVC boundaries. I prepared a little bit of code to show. Can you see my screen with the VS Code? Okay, cool. So this is my side project. I'm not disclosing any intellectual property here except my own. And use cases are implemented here as an afterthought. So just an illustration. I have a confirm action in a controller, and then I have a process withdrawal request use case that inside which I have a bunch of checks that are just, like very small functions that are checking, for example, that withdrawal request is latest, check it that it didn't expire, check that it wasn't paid before, etc., etc. And it has to do something with the price. for example, we want to know that it's the latest withdrawal request for this given price, and then I have a price service that exposes an API to work with the withdrawal request entity, which is underneath baked by the Ecto schema. But the application doesn't know anything about it. It's just, there is just a clean API, and I can do whatever I want with my price. I can move it from Ecto to another database, or it can become just a memory entity, whatever. And there is another service that is much smaller. It actually doesn't know even if it's baked by the Ecto or just something that is in memory. And if you want to know that if bad sleep was paid, we can ask it, or if a bad sleep is in the price group. And the thing is that it gives not only more accommodating structure for a richer domain, but also it adheres to single responsibility principle. I have my things that are just being, that are entities, and I have an API to work with them, and nothing leaks out. Okay, back to the presentation. I would say that encapsulation is like rigorous encapsulation is one of the most fundamental principles in software development. All of us heard many times that software development or one of the keys to success in software development is about managing changes well. And with the broken encapsulation, we cannot have that kind of control of what is going on inside our system. It's become interweaved and entangled, and something that is called a spaghetti code, and later the famous big ball of mud. And interactor object and orchestrating and using orchestration objects that are separating being from doing allows us to advance further towards more maintainable code bases. Just to recap, MVC is not enough. MVC is not a design pattern. I mean, it doesn't tell us anything about higher level design. MVC was initially introduced when UI logic becomes so big that it started to put additional complexity on an application domain. I imagine it was around a transition from pure CLI applications to the applications with UI elements, which could cause it an asynchronous, which could trigger asynchronous events in a system. And at that moment, view had to be separated from the model. There are many different, there are a lot of other approaches or a lot of other thinking paradigms, or how would you call it better, that suggests us or equips us with wonderful tools that can help us design more maintainable code and reduce our day-to-day suffering. For example, crafted design, clean architecture, crafted design introduced by Sandro Mancuso, clean architecture by Robert Martin, domain-driven design, just author's name flew away from my head. Ports and adapters by Alistair Cobar, DCI by Trygve Ringskauntan. Sorry, that's really a tongue twister. But I hope the I hope the idea is clear, because basically this is it. Everything that I had to say, and those are just some resources that I used to create this presentation, and where you can learn more, learn in more detail about the topics that I briefly touched. Thank you.
Awesome. Thank you, Yevhenii. Any questions? It was Eric Evans that wrote DDD. I was just looking for my copy. It seems to have gone missing.
That's a big book to lose, I think.
I'm pretty sure I borrowed it from someone else, so, you know, quid pro quo. Was there any questions?
Yeah, I'll jump in with a question. Would you include CQRS as an approach to help with this issue of contexts on their own, or becoming messy, I guess, or just becoming an active record? Because yes, there are CQRS libraries in Elixir that we can apply. So yeah, would you sort of say they are on the same level as, or at least an implementation of something like DDD or whatever?
Thank you, Robert. Thank you, Rob, for this question so much. I didn't want to put CQRS and event sourcing in the presentation because it's completely different paradigm. But I'm really happy that that you give me a chance to speak, to tell a few words about it. Actually, just a few days ago, I started to watch a lecture by Alan Kay, and interestingly enough, in his he's the guy who coined the object-oriented design, or object-oriented programming term. And in his opinion, his view of object-oriented programming is that messages cannot be a commands, right? The messages that objects are exchanging almost all the time should be events, something that had happened in the past, because they shouldn't be telling other objects how to change their state. Objects should be in control of their state. So absolutely, I do think that event-based systems, that is CQRS and event sourcing, they almost every time come together. And object-oriented programming, as an Alan Kay saw it, would help us to create more maintainable code bases. It's just a completely different paradigm. Doing an event-based system is completely different paradigm that I didn't want to bring in this topic because it's already quite large.
Yeah, no, that's fair enough. Yeah, I guess the way the very small amount of CQRS that I've done in Elixir is that the module that you would refer to as a context, as in the first the first layer down in your non-web directory of your Phoenix application, or the non-web application in your Umbrella app, that module initiated commands out to commanded in that case. So you could sort of call that a context because the user interface was calling into that. So yeah, these were live views. Yeah, so it's sort of a context. So yeah, but I take your point that it is it is slightly different because we weren't necessarily interacting with ecto models, schemas in quite the same way. But so I take your point that there is that distinction there. And it's a massive field. Like, we only just scratched the surface in a small app that we were working on.
And I think actually I took it a bit too far. You was talking just about CQRS, and I mixed event sourcing into it. I don't have experience with CQRS separately from event sourcing.
Right.
So I cannot say anything about that, unfortunately.
No worries. Cool. Thanks.
Thank you.
Yeah, I was going to ask a similar question. Yeah, I've also only done CQRS with event sourcing, but in that case, you're sort of forced to build a separate queryable read model so that you can efficiently populate a UI. Do you see there being a need to do that if you have a very rich domain model with an orchestration layer in between it? That can be a bit inefficient if you just need to do a bulk query and get some data out of the system to populate a UI, for example, or run a report or do those sort of things. So do you see value in having like a dedicated read model or some sort of, more data-oriented interface?
There is a nice company called Arkansas. I don't know if you heard about it. It's probably one of the best Rails shops in the world, and they're specializing exclusively on legacy software. So they're like like a last resort for big companies that is being called when the things are getting out of hand. And their last book, called Domain-Driven Design in Rails, suggests that event sourcing should be default approach in modern applications. My former, I had a conversation with my former team lead recently, and he quite agrees with that. He says everything in this world should be modeled as can be modeled as a process, right? As a string of events. So it's a viable approach for the application of any scale. I guess the hard part here is to do it right, because if you mess up with the events, that can be challenging to solve.
Yeah, I mean, I think I'd agree with making CQRS and event sourcing the default. But what we really are missing is sort of like the Rails or the Phoenix or what have you of the CQRS event sourcing world, just to nudge you in the right direction and get you started and make it convenient to sort of start that way. Because you're going to have to end up there at some point, and with greater auditability requirements and integrate. You really do need.
There kind of needs to be what I've seen the pattern happen on. I've done a few projects with event sourcing is that they kind of invent their own framework, because the framework's the really small part. Because if you use traditional Rails type thing, the Rails is huge or Phoenix is huge, and your application code is actually relatively small in relation to that. Whereas with event sourcing, it's kind of flipped around, so the framework's almost the trivial part, and then your code becomes really, really complex. So I think, yeah, it'd be nice to have like kind of a Lego style. Here's the thing, get an aggregate, get a an event, get a processor. But a lot of the time, the hard part is actually your code that will interact with that. So in some ways, it flips it around over your traditional kind of web framework type setup.
Is one of the things about sourcing. Sorry.
There you go.
Yeah, I think one of the things about the event sourcing is with the underlying representation, it's not really tied to the however you're persisting, and you sort of get to determine what that you can generate multiple sort of representations of that underlying data. And I think going back to active record and the sort of relationships you get there are determined by the relational sort of state of the database. Is one of the things about event sourcing. You can have a lot of events, but you can generate different views of that in your own code, rather than tying it to, okay, I've got this particular model representing, this particular active record model representing this object, where you get that sort of one-to-one mapping to objects and their underlying representation in the database.
Yeah, I mean, having done both ways, like rolling our own, but also using commanded, I definitely think picking something that, lets you focus on the actual problems you're solving, because you've got enough of them in CQRS event source world. Commanded is pretty helpful, and it nudges you in the right direction. It's probably not perfect, but it's better than nothing, I think. and it's
Well,
you can eject from it if you decide that its opinions aren't worth it relatively easily.
I worked on only on one project that used event sourcing, and we built everything from scratch. There are more entities that you have to use comparing to the typical layered architecture, but I wouldn't say. I mean, if people would like to play with it and experiment, there is no big barrier there is no big barrier in trying to roll it by yourself.